Hello, it's Chris Thomas again. This video is going to be about safe locations. Only this video I'm going to focus on the Pacific Northwest of the North American continent. So I'm going to focus on, well, we could cover British Columbia, my home province, Washington, Oregon, and northern California. These are basically the coast, and we may touch a little bit on the plains area, the eastern side here. So that's my intention in this video. Now, of course, when we talk about safe locations in the Pacific Northwest, that's the Pacific Rim. And so we have to talk about volcanoes here. So I'm going to go into volcanoes quite deeply, deep as I can, from a Planet X pole shift survival point of view. And of course, the companion subject of the volcanoes is prevailing winds. Prevailing winds make the difference, make and break the difference between dying in volcanic ash and gases, or happily coexisting with a volcano that is 100 miles away. So, prevailing winds. And of course, the other subject that keeps coming up on the channel is radiation exposure from leaking power stations, and this seems to be quite a fear out there. So we're going to cover radiation exposure and a few things like that, and nuclear power stations, and so that's what this video is about. And so we'll be heading into that next. Okay, so let's discuss radiation exposure. Now, radiation exposure is a very in-depth subject, so I'm going to try to break it down and make it as easy to understand as I can. And then I'm going to give you a common sense example of radiation in our food today, well, as of 2013, re Fukushima. And then we're going to finish up with a very good example of how people can live with radiation. Now, I'm not suggesting that we're going to park near a nuclear station and as our survival location, but I want to bring some sanity to the subject of radiation. Now, this what you see here is my Planet X newsletter, issue 2. It loads kind of slow because I was putting some awful big images into it, but my Planet X newsletters since issue 2 are much leaner in size. Anyways, so if I'll leave the link for people to read this, but this I wanted to start with this article. This article took me months to write, months. And because I took the basics of nuclear radiation and I explain it right here. Part 1, radiation exposure. Now obviously this is all from a food perspective and dispersal infective perspective, and a food perspective and a pole shift perspective. And I explain exposure, the substance of radiation, how it's traced, its natural form, which is one of them is thorite, that emits a radon, which is known as radon gas, which we've all breathed in. If you've ever walked into a basement, you're breathing radon gas. And now, also how it's found in the sea and how they measure it, and the ways in which they measure it. Now, I want to stop there because you see, first of all, we've had what is it, 2,000 or 3,000 atomic explosions or something like that. I'm just a wild guess since the Nagasaki and the Hiroshima, and it's filled the Earth's atmosphere with isotopes. And so when you're born, you start, the first thing you start breathing is radiation. So we live with it. That's called background radiation. Now there's also natural occurring radiation in the soil. But what we're talking about here is when nuclear material gets into the water or the air. That's where it becomes dispersed quickly. Now stay with me here, because if you understand radiation and how you get exposure to it and how it travels and the dosages, then you can calm down, because there's a lot of misinformation and dramatization from every other person talking about radiation in their blogs and their articles on the internet, trying to get hits, and they sensationalize radiation for the sake of getting hit counts on their website. This is not the kind of information that's reliable. So we have background radiation that we live with. And now the actual material of radiation comes in many different forms, because there are several elements that are radioactive. Some of the common ones you know of are uranium, plutonium. Some of the less known is thorite or thorium, and there are lots more. And when you're talking about radiation, you're talking about isotopes of radiation. Now, I'm not going to go into the extreme depths of discussion of radiative material and its parts, but I want to touch on how it's measured, because it's measured because radiation is a process. It's not it's a timed exposure. It's like if there's a hot fire burning, shall we say it's burning 100 feet away. It's a bonfire, and it's 100 feet away. It's not likely that the human skin will pick up the heat. But as you walk closer to the bonfire, you will feel the heat more and more. Now that is radiative exposure. That's exactly the same measurement idea when you with radiation. The closer you are to it, the more you are exposed to it. And also, you have radiation levels, which are radiative particles, isotopes of cesium, for example, which is common. So there are many graduative levels of measurement of radiation, and one of the very finer ones is called a becquerel. So if you're reading an article on radiation, exposure unless they discuss Becquerels, Curies, or Grays. The article is not accurate because there's a huge difference between Becquerel exposure and a sievert exposure. Huge difference. So, in my article, I discuss it, explain all this. So then I move on to, I broke it up into 3 parts because it's just too intense just to cover it all at once. And then so I get into part 2, which is after-time radiation in the sea, and discuss nuclear power stations and this kind of thing. And also, now I finish off with the part 3, which is discussing Chernobyl, 1986. And this is the good news, because there are many people living in these areas, in Chernobyl, that live with a level 7, like Chernobyl of 1986 was a level 7 event. It doesn't get any worse than that. And yet these women live quite happily out in the wild within a few miles of Chernobyl. Now here's a very interesting little story about the black redstart. The black redstart is a species of bird that lives near Chernobyl. This bird has been studied and found to have found a way to use the radiation to its advantage. So read the article here about the black redstart in Russia and how it learned, how its body responded to radiation and turned it around and made it into an advantage. So let's just go over to this little article here. I use this article in actually in my newsletter, in that article, in my article on radiation exposure in my Planet X newsletter, issue 2. If we take a typical restaurant-sized portion of Pacific bluefin tuna, 200 grams, it contains 5% of the radiation you get from eating one uncontaminated banana and absorbing its naturally occurring radiation. All the foods on the planet contain radiation. Like every other toxin, it's the dose of radiation rather than its simple presence that determines whether it's toxic to humans. So, as you can see, by eating a piece of fish, you're only getting 5% of the radiation you'd get from eating one uncontaminated banana. So read the article, read my Planet X newsletter stuff on radiation, and get your feet on the ground when it comes to radiation. So, now as it happens, now getting back to Pacific Northwest, there's one nuclear power station, the Columbia Nuclear Power Station in Washington. Here. Right in this location, right there. So you got one in the whole of Washington to look out for. So, now that's in counterpoint with what you have in the east of the U.S., which is many, many, many more nuclear power stations. So, but we're discussing the Pacific Northwest. We'll get into that later. So here we are in Oregon, there's none. Okay, one in Washington, and of course you've got a couple in, or 3 or 4 of them in California there. So radiation, learn about it. Understand that radiation is very, very, you have to be very specific when you're thinking about radiation. And so that's what I wanted to discuss about radiation exposure. But really, the crux of the work I've done on radiation exposure is in this newsletter. And if you read that, you'll understand that the radiation is not as bad as you may think. And as I've said, of course, we're not going to set up our safe locations near one of these. So let's get some facts and some sanity to the situation. Okay, so that is my little bit on radiation, and I'll put up the link to this newsletter article, and please read it. And okay, so that'll be it on this portion. Okay, let's discuss volcanoes. Now, we know the basic makeup of volcanoes. Let's go here. Here with volcanoes. This is Mount St Helens. So you can see you've got the flank of the volcano, and you've got the crater, and here you don't see the volcanic ash plume, and here you see the dome of hardened magma that's swelling in this case. But what I wanted to point out here is the vast area that is affected around the volcano. So it suggests that we be 50 miles from a volcano, and you can see now in the case of the Mount St Helens, the side of the not only the top but also the side of the mountain came away, and you can see that here in a video right here. This is Mount St Helens real-time video. Okay, and let's take a look down here at 1750. This is a time lapse. Of
this eruption on July 22nd was photographed on time-lapse by amateur photographer Jerry Whitaker of Woodland, Washington.
Well, this was, as you've just said, was taken from Woodlands, Washington. That's 25 miles away.
Meanwhile, a watchful eye.
Okay, so you can see the power of a volcano. So obviously being near a volcano is out. But in Washington and Oregon and Northern California, now we're not going to discuss Southern California because there's so many fault lines down here that, as I've said in previous in the previous video, survival is just I think it's almost impossible. You'd have to be very lucky to survive in Southern California or mid-California. So, but we're talking about this area here, basically here. So, all the volcanoes are down the coast here like that. So, now the thing about volcanoes is prevailing winds. So you don't think about volcanoes unless you think about prevailing winds at the same time. Prevailing winds remain the same, more or less the same, regardless of what position, what landmass, however Earth is positioned. Now obviously we're all used to Earth being positioned this way. Notice that they travel in a southwesterly direction to the equator. Now I'm talking about the northern hemisphere. Southern hemisphere is going to be northwest movement, like that, to the equator. So so these winds occur regardless of wherever there's a pole, whatever landmass is moved on Earth, however Earth has repositioned herself as far as her geography is concerned for a pole shift. The winds are going to remain the same. That's why they're called prevailing winds. Now I took this basic information here and I superimposed it onto a globe, and I drew in the new equator. This is, you can see this article piece in my same newsletter, Planet X newsletter issue, 2015 issue 2. So as you can see, the prevailing winds will be towards the equator in this fashion. And now there's a slight error here, at any rate, the winds will blow off coast. That's the whole point here. Now Zeta Talk tells us that now let me back up here for a sec. As you can see, the Earth has been tipped here 90 degrees, and that puts the whole west coast of North America, puts it basically in parallel with the equator. Now the equator is like this is because of the viewpoint. So this might be easier to explain. So all the prevailing winds will be going towards the equator like that. Okay, so what that's going to do is going to blow the plumes of the volcanoes out to sea. By the way, this picture was taken from Endeavour, the space shuttle Endeavour, September the 30th, 1994, of a volcano erupting in the Kamchatka Peninsula of Russia, eastern Russia, and this of course is would be our eastern Pacific. So this notice the pattern of the plume, and notice how far it goes. But more importantly, notice the slow and gradual expanse of the cloud. So this is what's going to be happening to these volcanoes here. Well, to all volcanoes in the northern hemisphere close to the equator. So we understand, I'm going to back up here, we understand that the coast of North America, the west coast, is going to lay on its side, and we're going to be within the trade winds that blow towards the equator in a southwesterly direction like that. So that's the whole point here for Oregon, Washington, BC, and California. All right, so let's take a look. So now we know, okay, that the mountains to the east of the volcanoes are relatively safe from volcanic ash, because the ash will be blowing out to the Pacific. So now let's take a look at the conditions, geological conditions of Washington, Oregon. Well, let's include BC and California. So what's happening is the Pacific is compressing. That means the oceanic plates here are being driven under this mountain, the mountain range here of the Rockies and the Sierra Nevadas, and the down into the sea areas down in this area here. So the plates are being pushed under. So what's happening will be that, for example, these valleys here will be boiling. The ground will be, if the rocks don't liquefy on the very edge, the ground at the bottom of the valleys will be unlivable, hot. The rivers will be boiling, the lakes will be boiling, and so will the sea be boiling. So obviously, west of the volcanoes will be a very intense place, and this is not recommended for survival. Now here you can see this is the dark blue is the pole melt. Now really that's not taking into effect at all. So let's take a look at it this way. So this would be the hour of the pole shift. So these light green areas are going to be very hot and unlivable. So now we're going to, now also the pole shift waves will be coming in right past my doorstep here, and coming into the into Seattle. Seattle, Tacoma is totally wiped out. This whole area is Portland, Eugene. This whole area is just completely wiped. But the Zeta talk tells us that obviously because of the subduction of the oceanic plates, that there's mountain building going on here. So this area here will raise up by 1,000 feet. So it may save something to do in not Seattle, but possibly up in more in the foothills here. It might be survivable up there, up in the foothills, but I wouldn't plan on it. But yeah, there will be, this whole area here will be lifted up 1,000 feet here. See. Now Vancouver Island is a bit of a different case. I'll cover that in the next segment. So okay, we got volcanoes, and we got a lot of action of heat in the valleys here. So not recommended here to be west of the volcanoes. Now if we're going to survive in Washington and Oregon, is very doable, and this area in the mountains here. Now, obviously you're not going to set up your camp next to a rocky mountain, but if you've got some type of reasonable land, let's take a look. Let's take a look at some of this land in here. Wow. Looks good to me. So we've got a lot of beautiful places to live. This is a little close to Mount Baker. It's Mount Baker. Mount Baker, I see it right across the water here. And so anything too close to Mount Baker won't be good. It's up in here somewhere. I think that's Mount Baker right there. So obviously this area here is not good. But these areas here to the right in the mountains look good. All these mountains look good here. As long as you're not close to one of these, here's Glacier Peak. There's a volcano right there. That's a no-no from there. But anywhere over here, because don't forget, when you're done with the pole shift, you're not going anywhere. And okay, so this is the same with each of these volcanoes as you go down down the coast here. Areas 100 miles around them or 50 miles around are not good, but to the right. So as you can see, there's a lot of land. Let's just take, if we were to take this block here, there's tons of land in eastern Washington that are, I'm sure it would be wonderful for survival. It's the same with Oregon. And if you look at the earthquake map, it still looks pretty good here. We're into yellow. Actually, we're into green, actually, which is quite good. So here's Western Washington. Here's your Oregon. And California gets a bit crazy, as you can see. But there's a few yellow areas here that are survivable in Northern California. Look at this. There's even a green spot here in California. So yeah, so we've got these areas that can work. So let's do a quick recap here. We've got the mountain range with volcanoes dotted every 50, 100 miles all the way down. So as long as we are to the right or to the east of those volcanoes and not too close, giving them a good 50 to 100 miles space, in the after time they'll be blowing out to sea. So this whole area in eastern Washington and Oregon and parts of what looks like parts of California, of northern California, more Nevada, eastern Nevada, except of course in Nevada, you got to be careful that you don't set up in an area where you have poor soil. You got to make sure you've got some good soil. So these areas are all livable, and also of course we're going to look out for the Washington Columbia nuclear station, so looking out for that. And so there's lots of space there. So that's what I wanted to cover on these states, and all the other lookouts have to be considered. For example, you don't want to be near a big city. You want to be, you really want a community that is isolated from the very large towns. So Spokane would probably, I don't know the population of Spokane, but it would be probably a couple 100,000. And so you don't want to be too close to these big cities, but there's lots of space here. That's the whole point. Now we're going to move right into Vancouver Island. Okay, so this is Vancouver Island. Now Vancouver Island, I live right here. Vancouver Island is a special case because it is on its own plate. It's called the Juan de Fuca Plate, and it is up against the North American plate and jammed underneath. And what happens during the pole shift is that being on its own plate, it's going to rise. You see, as the oceanic crust is going underneath the Juan de Fuca plate, the crust is underneath it. So the plate is on top. This is not, these drawings are not, they're not too descriptive, but the plate sits on top. No, Juan de Fuca plate sits on top of the oceanic crust and below the North American plate. So what happens with Vancouver Island in the pole shift, it actually moves, according to Zeta Talk, it moves 100 miles to the north. My guess is it'll also be pushed out slightly, so it'll be truly an island in the Pacific. If it isn't now, it will be even more so in the after time, because it rides on top of the oceanic crust as it's being compressed underneath North American plate. And so it's a little chip here that will ride on top of the subducting slab of the oceanic crust. Now, when I had my contactee experience, it was a bumping up experience. It was a bouncing experience. So that's the type of event that's going to happen to Vancouver Islanders. It will be a bumping up, a very bumpy, up and down bumpy ride. I know because I experienced it firsthand in my contactee experience when I first became aware of what was coming. So also Vancouver Island is being pushed upwards, apparently out of the water by about 75 feet. So this is what's happening to us here in Vancouver Island. So to conclude, this video on safe locations for Pacific Northwest, it's pretty clear that eastern BC, eastern Washington, and Oregon, little bits of northern California, and parts of Nevada here are quite good. We just need to make sure that you're not within 100 miles of these volcanoes, and that you're not close to the Columbia nuclear station. Now, on nuclear station, I want to just to remind, I forgot to mention this, and it's actually in my article, I think, but using potassium iodide, one should have a large supply of potassium iodide tablets for use for the first few years in the after time. Also, you don't want to be down river from a dam. That's important. And so, barring any of the obvious things, these areas is very, very survivable. Now, obviously, this goes off quite similar recommendation for Idaho, and except getting close to where the continental divide happens over along the Rockies here, where you have the plains intersecting with the mountains, and then this zone here. But that's I covered in another video, I believe, because these lands here are going to move 50 miles this way. 50 miles this way. So, but yeah, so that would be the conclusion of the video, and I'm hoping that I covered enough information to make a good decision Obviously, you'll have to look at your location closely against rock slides and land movement and water movement. But as I said, these areas look good to me. Thanks for watching.